My dear students, welcome back to our channel. In this video, I will be explaining the B.Ed second semester subject content and pedagogy of physical science education at secondary stage, as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 4 first important short question is: define teacher professionalism. Teacher professionalism means the skills, behavior, and attitude a teacher shows to do their job effectively and responsibly. A professional teacher is not just someone who teaches lessons, but is also a role model, keeps learning new things, and respects students, colleagues, and society. Professionalism includes strong subject knowledge, understanding science deeply. Good communication, explaining concepts clearly. Continuous learning, updating teaching methods and using technology. Ethics and values, being fair, honest, and respectful. Classroom management, maintaining discipline and a positive learning environment. Example: a science teacher who regularly attends workshops, uses experiments to make lessons fun, and motivates students to ask questions shows professionalism. Memory tip: think of a teacher as a scientist in class, always learning, experimenting, and guiding students responsibly. Next important short question is: to mention important skills of a science teacher. Important skills of a science teacher. A good science teacher needs a mix of knowledge, communication, and teaching skills to make learning interesting. 1. Subject knowledge. Clear understanding of physics, chemistry, and biology helps explain concepts correctly. 2. Communication skills. Explaining in simple words, using real-life examples. 3. Practical skills. Performing experiments, handling lab equipment, and demonstrating safely. 4. Creativity. Using models, videos, or activities to make science fun. 5. Questioning and problem solving. Encouraging students to think critically and ask questions. 6. Classroom management. Maintaining discipline and creating a positive learning environment. 7. Tech skills. Using digital tools like smart boards, animations, and virtual labs. Example: a teacher showing a volcano experiment and then explaining chemical reactions in simple terms makes students curious and confident. Quick tip: remember KCPC-QCT knowledge, communication, practical, creativity, questioning, classroom, tech. Next important short question is: 3. What is action research? Action research is a process where teachers study and improve their own teaching. It means teachers identify a problem in their classroom, try out solutions, and check if those solutions work. It is practical, small-scale, and focused on improving teaching and learning. Steps: 1. Identify a classroom problem. 2. Plan a solution. 3. Try it in class. 4. Observe results. 5. Reflect and improve. Example: a science teacher notices students find electricity experiments confusing. The teacher prepares simple diagrams and videos, tests them in class, and sees that students understand better. This helps the teacher improve teaching methods. Why it's important? Helps teachers become better and more confident. Solves real classroom problems. Makes learning fun and effective. Easy trick. Remember PTOR problem, try, observe, reflect. 4. Technology integration in teaching learning. Technology integration means using digital tools and technology to make teaching and learning more interesting and effective. In physical science education, It helps teachers explain difficult concepts visually and practically. For example, instead of just reading about the solar system, a teacher can use 3D models or videos to show planets and their movement. Tools like smart boards, projectors, educational apps, and simulations make learning fun and interactive. Students can also perform virtual experiments in science labs without worrying about safety or resources. Teachers can use PowerPoint presentations, animations, YouTube videos, and online quizzes to make classes engaging. Technology also helps in online learning, where students can access lectures, notes, and assignments from anywhere. In short, technology integration makes science teaching visual, practical, and exciting. It helps students understand concepts better, encourages curiosity, and prepares them for the modern world. Next important short question is 5. Professional growth. Professional growth means a teacher's continuous improvement in skills, knowledge, and teaching methods throughout their career. For a physical science teacher, this includes learning new science concepts, modern teaching strategies, and using technology to make lessons effective. Teachers can grow professionally by attending training programs, workshops, seminars, online courses, and conferences. They can also do action research in their classrooms to solve teaching problems and improve learning outcomes. For example, a science teacher may attend a workshop on robotics or coding and then include those ideas in lessons to inspire students. Reading journals, collaborating with other teachers, and joining teacher communities also help in growth. In short, professional growth is about being a lifelong learner. It makes teachers confident, creative, and better at helping students succeed. A teacher who keeps growing professionally inspires students to love science and learning. Next, Unit 9. Long questions. First important long question is 1. Explain the professional competencies required for a science teacher. Professional competencies required for a science teacher. A professional competency is the set of skills, knowledge, and attitudes that make a teacher effective in their job. A science teacher must have strong subject knowledge, teaching skills, and the ability to guide students in exploring and understanding scientific concepts. 1. Subject knowledge competency. A science teacher should have deep understanding of physics, chemistry, and biology concepts. Example, a teacher explaining Newton's laws should not just read from the book but also give real-life examples like playing cricket or riding a bike. 2. Pedagogical competency. Teachers must know how to teach effectively, choose suitable teaching methods, and make lessons interesting. Example, using models, experiments, and smart boards to explain concepts. 3. Classroom management competency. Science classes often include experiments, so teachers must manage students, materials, and safety. Example, creating lab safety rules before starting an experiment. 4. Communication and technology competency. A teacher should communicate clearly and use digital tools like simulations, videos, and presentations. Example, showing an animated video to explain how volcanoes erupt. 5. Assessment and evaluation competency. Teachers should be skilled in testing and evaluating students' progress using creative assignments and quizzes. Example, giving a project on solar system models to check understanding. 6. Research and innovation competency. Science teachers should be curious and keep learning. Example, attending science exhibitions or reading new research to update lessons. 7. Professional ethics and attitude. A teacher should be patient, motivating, and a role model. Example, encouraging weak students to participate in experiments without fear. Quick memory tip: remember SPCCARP. Subject knowledge, pedagogy, classroom management, communication and technology, assessment, research, professional ethics. These competencies help science teachers make learning fun, safe, and effective for students. Next important long question is: 2. Discuss formal and informal professional development practices for science teachers. Formal and informal professional development practices for science teachers. Professional development helps science teachers improve their teaching skills, update their knowledge, and become better educators. It can be formal, planned and structured, or informal, casual and self-driven. 1. Formal professional development practices. Formal practices are organized programs designed by schools, colleges, or educational boards. They are planned, certified, and structured to help teachers grow. Examples: workshops and training programs. Teachers learn to use new lab equipment or teaching technology. Example: a training session on using smart boards or simulations in science classes. Seminars and conferences. Teachers meet experts, discuss new teaching methods, and learn updated scientific knowledge. Example: a national-level science conference on climate change education. Courses and certifications. Teachers take extra degrees or online certifications to improve qualifications. Example: completing a certificate in STEM education. Peer observation. Teachers observe colleagues' classes to learn better techniques. Think of formal development as school or government-arranged learning. 2. Informal professional development practices. Informal practices are self-initiated learning efforts that teachers do in their free time. They are flexible, continuous, and personal. Examples: self-study, reading science journals, books, or online resources to stay updated. Collaboration with colleagues, sharing ideas and tips with other teachers during lunch breaks or staff meetings. Online communities, joining teaching forums, WhatsApp groups, or YouTube channels to explore experiments and methods. Learning by experience, gaining practical knowledge from classroom experiments or handling student questions. Example: improving lesson delivery after noticing students' reactions in class. Think of informal development as self-motivated learning. Quick comparison: formal, informal. Structured and certified, flexible and self-driven. Conducted by schools, universities, or government, done individually or with peers. Examples: workshops, seminars. Examples: reading, networking. Both practices are important. Formal learning gives teachers new skills and recognition. Informal learning helps them grow daily through curiosity and experience. Together, they make science teachers confident, updated, and inspiring. Next important long question is: 3. Describe the role of teacher as a researcher in physical science. Role of teacher as a researcher in physical science. A teacher as a researcher means a teacher does not just teach but also studies their own classroom, students, and teaching methods to make learning better. In physical science, a teacher becomes a scientist in their own classroom, observing, experimenting, and improving teaching techniques to help students understand concepts better. 1. Observing classroom challenges. Teachers watch how students react to experiments or topics. They notice if students are confused, bored, or excited. Example: if students struggle with electric circuits, the teacher studies why and finds simpler experiments or diagrams to explain the concept. 2. Experimenting with teaching methods. Just like scientists experiment in labs, teachers experiment with teaching strategies. They try different tools, videos, models, simulations, and see which works best. Example, replacing textbook-only teaching with hands-on experiments to see if students score higher. 3. Collecting and analyzing data. Teachers gather data by checking test scores, asking feedback, or observing group work. This helps them identify what works in teaching science. Example, tracking student improvement after introducing simple science kits in class. 4. Solving real problems. Teachers research classroom problems like: why do students fear physics formulas? How to make chemistry labs safer? They find practical solutions and share them with other teachers. 5. Continuous professional growth. By doing small research projects, teachers stay updated with scientific methods. This makes them confident, creative, and respected. Example, writing a paper on low-cost physics experiments for a teacher training seminar. Summary table. Teacher as researcher role example. Observe classroom issues students fear electric circuits topic. Experiment with methods use models instead of only lectures. Collect and analyze data compare scores before-after experiments. Solve real problems make labs safer with simple tools. Share knowledge present findings in workshops. In short, a science teacher as a researcher acts like a scientist in education, always experimenting and improving their teaching to make physical science exciting, easy, and practical for students. Next important long question is: 4. Explain the professional ethics and code of conduct for teachers. Professional ethics and code of conduct for teachers. Professional ethics are moral principles that guide teachers in their behavior and decision-making. The code of conduct is a set of rules teachers must follow to maintain discipline, fairness, and respect in the teaching profession. A teacher is not only a subject expert but also a role model, so their actions shape students' character. 1. Commitment to students. Teachers must treat all students equally, without discrimination based on gender, caste, religion, or financial status. Example, a science teacher encourages both boys and girls to participate equally in lab experiments. 2. Integrity and honesty. Teachers should be truthful, avoid favoritism, and present knowledge accurately. Example, explaining both successes and failures of scientific experiments to build trust. 3. Respect for colleagues and school community. Teachers should collaborate with peers, respect administrators, and maintain harmony in school. Example, sharing teaching materials with other teachers instead of competing. 4. Professional growth. Teachers should continuously update their knowledge through workshops, seminars, and research. Example, attending a low-cost science models workshop to improve teaching methods. 5. Responsible use of resources. Teachers must use laboratory equipment, school funds, and time wisely. Example, demonstrating safe handling of chemicals to students. 6. Confidentiality and care. Teachers should keep students' personal information private and show care in handling sensitive issues. Example, helping a student struggling with physics concepts privately instead of mocking them in class. Summary table. Ethical principle: what it means. Example in practice. Equality and fairness: treat all students equally, give equal lab chances to every student. Honesty and integrity: be truthful, avoid bias, explain real-life examples honestly. Respect and cooperation: work well with others, share notes and resources. Continuous learning: improve teaching skills, attend training programs. Care and confidentiality protect student information, support students privately. In short, professional ethics and code of conduct make a teacher a role model, ensuring they teach with honesty, fairness, and care while inspiring students to love learning. Next important long question is 5. Discuss the qualities of an effective secondary school science teacher. Qualities of an effective secondary school science teacher. A science teacher at the secondary level plays a big role in shaping students' curiosity and love for science. An effective science teacher not only teaches concepts but also inspires students to think, explore, and experiment. Below are key qualities. 1. Strong subject knowledge. A teacher must have a clear understanding of physics, chemistry, and biology concepts to explain them in simple ways. Example, explaining Newton's laws using a cricket ball instead of just a textbook diagram. 2. Good communication skills. Science teachers should explain difficult topics in simple, clear language that students can easily understand. Example, using local language or stories to explain scientific principles. 3. Practical and experimental skills. Science is best learned by doing. A good teacher uses experiments, demonstrations, and models. Example, showing a volcano model to explain chemical reactions. 4. Creativity and innovation. Teachers should use creative teaching aids like charts, videos, or science games to make learning interesting. Example, turning a classroom into a mini lab using low-cost materials. 5. Patience and empathy. Some students may struggle with scientific concepts. A teacher must be patient and supportive. Example, spending extra time helping a student understand electricity circuits. 6. Continuous learning. Science is always changing. A teacher should keep learning new discoveries and teaching techniques. Example, attending a workshop on artificial intelligence to teach its basics in class. 7. Good classroom management. An effective teacher keeps the class disciplined and focused. Example, assigning small science projects to groups to encourage teamwork. Quick recap table. Quality why it matters. Example. Subject knowledge builds student confidence, explains laws with real-life examples. Communication makes science easy to grasp, use simple language and visuals. Practical skills encourages exploration, hands-on experiments. Creativity keeps students engaged, science games, charts. Patience and empathy supports all learners, extra help for weak students. Continuous learning keeps teaching updated, learn new methods, attend workshops. In short, an effective science teacher is knowledgeable, patient, creative, and inspiring. They make science fun, practical, and easy to understand, encouraging students to explore and innovate.